Hello guys, welcome to last episode of set theory. In this video, we're going to be discussing about complement of set, and this is the fifth part of the set theory. The first four parts will be linked in the description. You can go and watch them. And the textbook which I'm using is Ncert textbook of 11th standard. I'll put the link of this textbook in the description too. You can download that textbook for free. So let's get started. So today's concept is complement of set. So complement of set is basically in terms of Venn diagram. If I want to express, suppose this is your set A, and if I want to say, and this is your universal set, which is this whole rectangle. If I want to say what is complement of A, so this is A. If I write a dash on that top of the A, it's called complement of A. It's read as complement of A. Complement of A. Complement of A is basically everything apart from A, or in other terms, U minus A. Like U minus A. What are the things which is there in this Venn diagrams which is apart from A? This area. So U minus A is equal to A dash. So this is basically complement of set. So if you want to write in terms of the exact definition, complement of set is basically A complement equal to set of all x such that x belongs to universal set and x doesn't belongs to A. So basically in the complement of A, it's everything apart from A. For example, suppose you have universal set is equal to 1, 2, 3, 4, 5, 6, and then you have A equal to 1, 3, 5. If they ask you to find A complement is basically universal set minus A set. So just have to remove A from the universal set. So just cancel, 3 cancels, 5 cancels, and this set remaining you write it over here. So 2, 4, 6, 2, 4, 6 are the remaining elements of this particular universal set. I hope you get a clear idea of what complement of a set is. So now let's get into the properties of complements of set. Okay, the first property is A union A complement is equal to universal set, and A intersection A complement is phi. So let us try to understand using this using a Venn diagram. So you have this universal set and you have this A set. So your A complement is basically this whole area. This whole area is A complement, like the empty area is your A complement, and this area is your A. So this area is A. Now they're saying if you unite this area with A complement area, like red area plus blue area is going to give you total area, which is universal set. So that's why. And the next one is A intersection A complement is phi. So this red area and this blue area, what is common in between these two? Nothing. There is no common element or common thing between these two sets. So that's why A intersection A complement is phi. Now the next one is the important one, which is De Morgan's law. So De Morgan's law, he gave this beautiful property of complementary offset. It basically says A union B whole complement is A complement intersection B complement. It's like turning everything into opposite side. So just like how you let's say imagine you have minus 3 minus of minus say plus 4. So if you want to multiply this minus to the numbers, how are we going to do this? So this is, we'll take this as minus 1, you multiply this, everything gonna starts flipping. So this starts flipping into minus 1, and this starts flipping into plus, and this starts flipping into minus 4. So this is what happens, right? So in the exact same way, in terms of that, you can't directly relate this, but to give you a rough idea, I did this. So in the exact same way, if you use complement, everything is going to start flipping. So apply complement to this one, it gets, so A becomes A complement, and you apply this to this union, it turns into intersection, and you apply to the next one, it becomes intersection. So A union B whole complement. So apply complement to all of the things. So if you apply to this, it becomes A complement. If you apply to this, it becomes reverse. So union becomes intersection, and vice versa. And then if you apply to this, it becomes complement. In the exact same way, you can do the reverse also. So you have A intersection B whole complement. So start applying complement to the first. So this becomes A complement, and this reverses its from. So if you have intersection, it becomes union, and if you have union, it becomes intersection. So that it's just flipping from one to another. And then you apply to the B, it becomes B complement. This is the first one. So this is De Morgan's theory. You can even apply to this for every single place. Say for example, you have A complement union B whole complement. Now apply to the first one, which is A complement. So you have A complement, whole complement. So complement gets neutralized, and then you get with A. Now we're going to discuss in the next one, but I just told you right now. So complement get cancelled, and you get only A. And you apply the complement to this. So this turns, it becomes intersection, and apply complement to to B. You're going to get B complement. Now sometimes in the question you need to do the reverse. So you need to know how to do the reverse also. So imagine you take complement common from this. So in that case, if I take complement common, I have to reverse every single thing which I did. So A complement union B whole complement equal to this. So sometimes you need to reverse this from this and this from this. So in that case, you can take this whole complement, and you need to make sure that if you simplify this, you should be getting this back. So that's the second property, which is De Morgan's law. Extremely important. Please note this thing down. And the next two properties is law of double complementation. So we did this earlier. So A complement whole complement. So complement kind of like cancels out, and you get A. So you can verify this using Venn diagrams also. So the next one is law of null set and universal set. So if you take complement of null set, you're going to get your universal set. How is this? Emptiness, like emptiness opposite is what? Fullness. So if you take complement of emptiness, you're going to get fullness, which is universal set. And the exact same is opposite. If you take complement of fullness, so complement of universal set is emptiness, which is empty set. So that was the properties of complement set. Now we're going to discuss the exercise problems, exercise fifth one. So I'll write all the questions, so please keep a note on this. So the first problem is universal set equal to 1 2 3 4 5 6 7 8 9 9, A equal to 1 2 3 4, B equal to 2 4 6 8, C equal to 3 4 5 6. We're supposed to find A complement, B complement, A union C whole complement, A union B whole complement, A complement of whole complement, B minus C whole complement. So let's start with the first one, which is A complement. A complement is basically, as I told you, by definition, any complement set is equal to universal set minus that set. So U minus A. So you have to subtract A from universal set. So 1 2 3 4. So these. So you have universal set equal to 1 2 3 4 5 6 7 8 9, and then you have A equal to 1 2 3 4. So just have to cancel U from A. So cancel these four common elements, so they get cancelled, and the rest let's sit here. So 5 6 7 8 9. So same thing goes for the second one also. So you guys please try that and tell the answer in the comments. So B complement equal to universal set minus B. So try that. Third one, A union C whole complement. So first we're supposed to find A union C. So we should supposed to unite these two sets. So let us merge them. So A union C equal to A union C equal to 1 2 3 4 5 6. Now you're supposed to take, so whole complement is basically universal set minus A union C. So you're supposed to subtract this from this set. So this is your A union C set. Your universal set is 1 2 3 4 5 6 7 8 9. So remove this from this. So 1 1 2 2 3 3 4 4 5 5 6 6. So rest elements just list it over here. So 7 8 9 7 8 9. So you can use the De Morgan's law also. It's left to you. So how do you solve by using De Morgan's law? So this A union C whole complement I can write A complement intersection C complement. So first find A complement and then find C complement and then take the intersection. You're going to find the same type of elements. So try solving the fourth one, which is similar to third one. Next one is fifth one, A complement whole complement. So according to property, as I told you, these two gets cancelled out. So you get, like, imagine they get cancelled out, and then you get A as your answer. So which is 1 2 3 4. Last one, B minus C whole complement, which is basically universal set minus B minus C. So let's find B minus C. So B minus C. So this is your B 2 4 6 8, and this is your C 3 4 5 6. So your B minus C is going to be cancel the similar elements. So 4 is similar, cancelled, and then 6 is similar, get cancelled. So remaining elements of B, write it over here, 2, 8, and then we are supposed to take this universal set minus this set. So what are the common elements? 2, 8. So cancel 2 and cancel 8, and the rest of the elements write it over here, which is 1, 3, 4, 5, 6, 7, 9. So this is the answer for the last one. I hope you guys have a good idea of how this works. So now let's try to solve the second problem. So the second one is your universal set equal to A, B, C, D, E, F, G, H. We are supposed to find the complement of these given sets. So it's easy. I'll solve the first one. Remaining problems try to solve on your own. So A equal to A, B, C, D. We're supposed to find A complement, which is basically a universal set minus A. So universal set is A, B, C, D, E, F, G, H. So this minus this, right? So cancel the common elements, cancelled. So list all the elements in this. So that's your answer. D, E, F, G, H. So it is literally same for the rest of the problems. So try solving them. So the third problem is, if universal set is taken as set of all natural numbers, we are supposed to find the complement of these following sets. So let's start with the first one. So set of all x is that x is an even natural number. So you have your natural numbers like this. So 1, 2, 3, 4, 5, 6, 7, 8, so on. If you remove all the even natural numbers, so you have even natural numbers being removed, what are all the numbers which are left with? 1, 3, 5, 7, 9, which is all odd numbers. So the answer is set of all x is that x is natural number and x is odd number. You can write like this. You can either write like this or you can write yeah, it's best to write like this only. So the next one is set of all x is that x is odd natural number. So if you remove all odd numbers from natural numbers, what are you gonna get? So we're gonna do, so 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is your universal set. So if you remove all odd numbers from this, so 1, 3, 5, 7, 9 are removed, what are all the numbers you're left with? Even numbers, 2, 4, 6, 8. So you're left with all even numbers. So answer for this is set of all x is that x belongs to natural number and x is even number. That's all. Next one. Set of all x is that x is positive multiple of 3. So you have your set like this. So 1, 2, 3, 4, 5, 6, 7, 8, 9, so on. So if you remove all the multiples of 3, so 3, 6, 9, what are all the numbers you're left with? The numbers which are not the multiples of 3. That's all. So set of all x such that x belongs to natural numbers and x is not multiple of 3. That's all. So here set of all x is that x is a prime number. So if you remove prime numbers from natural numbers, what are all the numbers you're left with? Composite numbers and 1. Remember always, 1 is neither prime nor composite. You should not take in either as a prime number or a composite number. So if you take all the prime numbers from natural numbers, you are left with composite numbers and 1. So here set of all x is that x belongs to natural numbers, x is composite number and x equal to 1. So in that way we didn't exclude 1. So that's the answer for the fourth one. Fifth one, set of all x is that x is natural number divisible by 3 and 5. What is the complement? Which is not divisible. That's all. Set of all x is that x is natural number and x is not, so this is number, okay, it's x is not divisible by 3 and 5. Easy. Next one, set of all x is that x is a perfect square. So if you remove all the perfect square, what are you left with? The numbers which are not perfect square. That's all. Easy. Set of all x is that x belongs to natural number and x is not a perfect square. Exact same thing goes for this also. Set of all x that x is a perfect cube. If you remove all the perfect cubes, you're left with the numbers which are not perfect cubes. Set of all x is that x is a natural number and x is not perfect cube. So the eighth one is set of all x is that x plus 5 equal to 8. So let us try to write this in set builder form. So x plus 5 equal to 8, x equal to 8 minus 5, that is equal to 3. So your x equal to 3. So we have to, so this is basically 3. So you have to remove 3 from the natural numbers. So if you remove 3 from natural numbers, it's going to look like this. So 1, 2, not 3, 4, 5, 6, 7, 8, 9, and so on. Here we have 2x plus 5 equal to 9. If you solve this, you're going to get 2x equal to 9 minus 5, which is equal to 4, and x equal to 4 by 2, which is 2. So you have to remove 2 from the natural numbers. So if you remove 2 from the natural numbers, it's going to look something like this. So 1, 3, 4, 5, 6, 7, 8, 9, and so on. So here we have set of all x that x is greater than or equal to 7. So what are all the numbers here? So greater than or equal to 7. So that you have to include 7 also, because equal to sign is there. So 7, 8, 9, 10, 11, 12, and so on. So our universal set, as I told you, is 1, 2, 3, 4, 5, which are all the natural numbers. 6, 7, 8, 9, 10, 11, 12, so on. So if you do u minus this following set, so let's cancel the common elements 8. So everything from here gets cancelled out. So you'll be left with these numbers. So your answer for this is 1, 2, 3. So complement of this set is this. So 4, 1, 2, 3, 4, 5, 6. Last one, set of all x is that x is a natural number and 2x plus 1 is greater than 10. So if you deal with this kind of problems, just assume this as a normal equation and try to solve that. So 2x plus 1 is greater than 10. So 2x greater than 10 minus 1, 2x greater than 9, 2x I got 9 by 2. So x greater than 4.5. So what are all the natural numbers greater than 4.5? Starts with 5, 6, 7, 8. So answer for this is 5, 6, 7, 8, 9, and so on. So if you remove all these numbers from our natural numbers, which is universal set, your answer is going to be, so this is your universal set. So this is this set. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So if you remove this, basically everything from here gets removed and you're left with these numbers. So your answer for this problem is 1, 2, 3, 4. So this was the third main. So let us now discuss the fourth one. So the fourth one, if universal set equal to 1, 2, 3, 4, 5, 6, 7, 8, 9 and a equal to 4, 2, 4, 6, 8, b equal to 2, 3, 5, 7, we have to verify that a union b whole complement equal to a complement intersection b complement, basically De Morgan's law, and this one. So let us try to solve the first one. So LHS equal to a union b whole complement. So let us try to find this one. So let us find first. So this is basically universal set minus a union b. So first find a union b. A union b is merging these two sets. So 2, 3, 4, 5, 6, 7, 8, and your universal set is 1, 2, 3, 4, 5, 6, 7, 8, 9. So if you remove this from this, so cancel. So these are the elements which get cancelled. You're left with 1 and 9. So the answer for this is 1, 9. So this is your LHS. So now let us find the RHS. So right hand side RHS, left hand side LHS, we got 1, 9. RHS is A complement intersection B complement. So first find A complement, which is U minus A is equal to, so everything apart from, so remove the, so this. So we have to write 2, 3, 5, 7, 9 as our answer. So 1, 3, 5, 7, 9. So this is your A complement. So B complement is going to be U minus B, which is 1, 4, 6, 8, 9. So this is your B complement, this is your A complement. Now we have to take the intersection between these two. So if you take intersection between these two or the common elements, so what are the common elements? 1 is common, and what else? 9 is common. So the answer for this is 1, 9. So this is our RHS. Now is LHS equal to RHS? Yes, 1, 9, 1, 9. So we can say LHS equal to RHS, hence proved. So in the exact same way you can prove this also. So please try to solve this. So now let's move on to the next one. which is drawing Venn diagrams. So this is the fifth one. You're supposed to draw the Venn diagrams. So the first one is A union B whole intersection. So this is our Venn diagram. So this is our A and this is our B. Assuming they're intersecting, assuming they're not disjoint set. So A union B. So this is our A and this is our B. And this is our A union B, isn't it? So everything which is there in A and B, it's A union B. So they are saying the complement, which means everything apart from A union B, which is this area. So this area is your A union B whole complement. Next one is A complement intersection B complement. So I can write this as A union B whole complement. I can write this as like this using De Morgan's law. So again, the answer is exactly same. So next one is A intersection B whole complement. So this is A and this is B. So A intersection B is this. So this is our A intersection B, and they're saying whole complement, which means everything apart from this area. So which is this. So this is your A intersection B whole complement. Next one is A complement union B complement. If you use De Morgan's law, it's something like this, which is exactly same. So this is how you solve these kind of Venn diagrams. So always try to use De Morgan's law as possible, so that you can convert into this, and then it becomes more easier to express. So the sixth one is, let universal set be the set of all triangles in a plane. If A is the set of all triangles with at least one angle is 60 degree, what is A complement? So they're saying your set A equal to set of all triangles with at least one angle is 60. So triangles with at least one angle is 60. One angle is 60 degree. So what is going to be your A complement? Considering U is set of all triangles in a plane. So U is a set of all triangles in a plane. What is going to be your A complement? Your A complement is going to be a set of all triangles with all angle. Here at least, which is minimum. Here everything, it's exact opposite. So at least one angle is 60. Here all angle is going to be 60. All angle is 60. Now what is a triangle which has all angle as 60? Equilateral triangle. So only equilateral triangle as all angle as 60 degree in its triangle. So I can say A complement equal to set of all equilateral triangle. Set of, simply I can write like this, or set of all equilateral triangles, lateral triangles. So this was the sixth one. The answer for the sixth one is this. Next one, fill in the blanks. So A union A complement. So you solve this best using properties of complements of set and use Venn diagrams to solve these kind of problems. So you have A union A complement. You have your A set here. So this is your A set and this is your U. So this is your A set A and this is your A complement. So everything apart from A. So this is your A complement. So if you merge those two, what are you going to get? If you merge the blue area with red area, you're going to get whole total area, which is U. So this is U. Next, phi complement intersection A complement. Phi complement intersection A. So emptiness complement, as I told you, is universal, which is, so I can write like this as U universal set intersection A. So what is common between universal set and A? So this is your universal set and this is your A set. What is common between universal set and A? A itself. So answer is A. Next one, A intersection A complement. So this is your A complement and this is your A. What is common between red and blue region? Nothing. There is nothing common. So answer is empty set. So universal set complement intersection A. So universal set complement is emptiness. So as I told you, fullness opposite is emptiness. So empty set intersection A. So what is common between empty set and A? Empty set itself. So answer for this is empty set. So this was the end of the chapter. So if you learn something new, make sure to hit that subscribe button and that notification bar, and I meet you in the next video. Thank you so much for watching.